Hello students, yes we are live now, and in this video lecture we are going to discuss about atomic mass. Okay, in the last class we have already discussed about the different structure of an atom, and also we have discussed how the subatomic particle has been rearranged inside an atom, right? So in this video lecture we will discuss that how can we calculate atomic mass and what is the relation between the atomic mass and the atomic numbers. So can you tell me, dear students, what is atomic number? Can you tell me? Do you have any idea that what is atomic number? Atomic number is nothing but the number of proton, isn't it? Number of proton present inside an atom. That's we call atomic number. And that number of proton is nothing but that is equal to number of electron, right? The number of proton in an atom is equal to number of proton. That's why we used to say that the charge of an atom at number of electron is equal to number of proton. That's why we can say that the charge of an atom is nothing but its neutron. Okay, we can say that it's neutron. Why we can say this one? Because the number of electron or number of negative particle is equal to number of positive particle, right? Okay, so let's see what the atomic number says. That as the number of electron is equal to number of proton, can we say that the number of proton is equal to number of neutron? No, maybe it's possible, and in some case it's not possible also. Okay, so let's see what is atomic mass. Atomic mass, the unit is AMU, or we can write down as 1 unit. Atomic mass is nothing but the mass of an atom, right? So let us consider a thin container. Okay, let us consider a thin bag which is not having a considerable mass, okay, or ignorable mass. Okay, and if we will put some substances in it, then what will be the mass of the container, or what will be the total overall mass? That if we want to put that container on a weighing machine, then we will see that mass will be nothing but the combination of all the stuffs which we have kept in that particular bag, right? Similarly, an atom has the atomic mass that is nothing but the combination of electron, proton and neutron. Okay, so if we will say that the mass of the electron is just negligible, okay, that's why when we want to measure the mass of an atom, then we generally consider the neutron and proton. Now, how can we calculate atomic mass? It is nothing but the combination of all the subatomic particles present in the particular atom, right? That is nothing but the electron, the nucleus, which is composed of neutron and proton, right? And the combination of electron, proton and neutron, that is nothing but the overall mass of an atom, right? But as the mass of the electron is negligible, that's why we can say that the atomic mass is nothing but the combination of, we can ignore this one. We can say that the mass of the atomic mass is nothing but it equals to number of proton plus number of neutron. Okay, so let us take different examples and let's try to understand how can we calculate atomic mass. Okay, so the atomic mass, we will discuss about the different elements. Like, let us consider an example like helium. In helium, we can see that the atomic mass of helium is 4. It is combination of number of neutron and number of proton in it. Clear? So it is here we can see that the number of neutron and proton is similar in the atom. In the atom helium is having atomic mass 4 atomic mass unit. Now this 4 atomic mass is nothing but it is combination of what? It is combination of number of proton in it plus number of neutron in it. Number of proton is 2 and the number of neutron is 2 in case of helium, right? Similarly, we can take another example like calcium. In case of calcium, its atomic mass is 14 AMU, atomic mass unit, and this 14 AMU is nothing but the combination of number of proton plus number of neutron. Number of proton is 20 and number of neutron is 20. So the overall mass is nothing but it's 40, right? Similarly, now let us consider an example like fluorine. In this case, number of electron or number of proton is not equal to number of neutron, like element like helium or lithium. Okay, so what will happen in this case? In this case, atomic mass of the fluorine is nothing but its 7 is nothing. So in this case of fluorine, the atomic mass is nothing but its 19. How does this happen? As we know that in case of fluorine, the atomic number of fluorine is equal to what? The fluorine is 9, right? So the number of protons should be 9 as well as number of neutrons should be 9. But in this case, number of proton is 9 and number of neutron is 10. Okay. So what will be happen? That the total atomic mass. Now the atomic mass for fluorine, will be equal to number of proton plus number of neutron. That will be equal to 9 plus 10, which will be equal to 19 AMU, atomic mass unit, right? So how does this happen? As here the number of neutron is not equal to number of proton, so that's why we can say that the mass is not exactly equal to number of twice the number of the proton or twice. Okay, let's consider another example like aluminum. In case of aluminum, we can say that the atomic mass is, in case of aluminum, it's 27, right? But we can see over here that number of proton is 70, and means to say its atomic number or number of electron is 70, right? But the number of proton, the number of neutron is over here, it's nothing but it's 14. Okay, so here we can see that as the number of neutron is 14 and number of proton is 13, so we can calculate the atomic mass. What will be the atomic mass over here? And now we can calculate atomic mass of aluminum will be equals to number of proton plus number of neutron, and number of proton is equals to 13 and number of neutron is 14. So now this will be equals to 27 AMU, atomic mass unit, right? So atomic mass of the aluminum is 27 AMU. It's nothing but the combination of number of neutron plus number of proton. But here this 13 proton is nothing but equals to number of electron. Okay, so in case of aluminum, the number of electron, or in any atoms, we know that the number of electrons is equal to number of proton is equal to atomic number. Okay, keep it in your mind. The number of electron is equal to number of proton is equals to atomic number. Okay, only the number of neutron only get changed in different atoms, right? Okay, so let's take another example like chlorine. In case of chlorine, what is the atomic mass? Okay, so let's see that in case of chlorine, we know that there have atomic mass 35 and also 37. So what will be this? In this case, in case of chlorine, we can see that there is 17 proton and 18 neutron. There is 17 proton and 18 neutron. So what will be the mass? Mass will be 35. But at the same time, another atom of chlorine have the number of proton is 70 and number of neutron is get changed. Number of neutron is 20. So now what will be the atomic mass over here? Here the atomic mass will be 37, right? 37 AMU. So what will be the relation between such kind of different types of atom of a particular element? So this is nothing but this is called isotopes. Okay. So in the upcoming class we will discuss about the more such examples which are having the number of neutron that is different from number of proton, and also we will discuss about such elements which are having different atomic mass. And what does this say? The atom or a particular element which having atoms are having different atomic mass, that is called isotopes. Okay, and about that we will discuss in our upcoming class. Thank you dear students. Stay safe, take care. Thank you.